Researchers from the Wake Forest Institute for Regenerative Medicine used an integrated tissue organ printer to 3D bioprint a trachea. Now, researchers have 3D printed tracheal splints and scaffolds to grow tissue-engineered tracheas in the past, but this is the first time that a trachea was created with multiple functional materials. Previous attempts failed because they only used regenerative cartilage tissue. According to the researchers, they weren't strong enough to hold the airways open or provide the necessary flexibility. Well, these constructs were printed with cartilage and smooth muscle regions at the same time, using a biodegradable polyester material and stem cell hydrogels. The cartilage provides enough support to avoid collapse, and the smooth muscle provides the needed flexibility. The proof of concept could one day lead to custom patient care for those suffering from things like tracheal stenosis or a narrowing of the windpipe. Now, these patients need breathing tubes. In the future, we could use their own medical records to print biocompatible replacements. Next, the team will test long-term functionality to make sure the 3D bioprinted tracheas maintain their initial characteristics. And the school has done some pretty impressive work in the past. They've worked on everything from 3D printing human ears to growing livers, kidneys, and even anal sphincters in the lab. Researchers from Oak Ridge National Laboratory are using a new 3D printing technique to improve lightning strikes on airplanes. Airplane exteriors are traditionally made of carbon fiber reinforced plastic. It's lighter than metal, but its low electrical conductivity and heat resistance make it vulnerable to lightning strikes. Common lightning strike protection technology includes expanded metal foils and films on top of composite structures. I mean, this technology works, but it increases the weight, corrosion, and it's expensive to add and repair. The Oak Ridge researchers created a new adhesive material for carbon fiber reinforced plastic, and the material has proven effective against lightning strikes. The polymer has a chain-like structure that makes the aircraft components both electrically conductive and structurally strong with thermal treatment. And it's applied in layers that are only 0.25 to 0.4 millimeters in thickness. Now comes the fun part. The researchers had to test it. So it conducted simulated lightning strike tests. The parts not only showed minimal damage, but also enabled more uniform heat dissipation, suggesting that it could eventually lead to more effective lightning strike protection technology in the future. This week, Now Lab introduced Loki, a prototype for a 3D printed autonomous podcar designed for last mile movements. Now Lab is the additive manufacturing innovation arm of the Big Rep consultancy, the team behind the Nira e-bike, a 3D printed electric motorcycle, and smart concrete walls that have embedded sensors. First seen on New Atlas, the podcar has airless tires, embedded electronics, and wireless connectivity to transport you through dense urban areas. Or I mean, really wherever you want to go. Now Lab envisions podcars being manufactured on demand using a fleet of Big Rep's 3D printers. One highlight of the prototype is that if you need a new component or part, you just scan the NFC chip in the part with your phone and send it to the 3D printer. I mean, I could just really use this functionality on my Yaris right now. The latch on the change cup breaks and they want more than $1,000 to replace the entire dash. Don't think so. The team could also integrate sensors to monitor parts for preventative maintenance. According to the company, the podcar was developed using parametric modeling. The design is flexible not only in that it can be printed on demand, but different features and materials or even tires can be swapped out based on the location or application. According to the company, Loki only has 14 unique parts, all of which were 3D printed on Big Rep additive manufacturing systems. Even the tires. See, Nissan wanted to solve the last mile problem with a built-in scooter. This just seems a lot cooler. I'm David Manti. This is Engineering by Design.